All right, let's do lesson 3.05, Parallel Lines and Transversals, Part 1. Oh, I found another little comic. This little guy's saying I had my doctor do a DNA blood analysis, and as I suspected, I'm missing the math gene. So some of you think you're not that good at math. You might be missing the math gene. And yes, it's only a joke. Okay? Don't be taking that seriously. All right. Where's my little thing that tells me to click? There it is. Okay. The objectives in this lesson, 305, are to identify special angle pairs formed from two lines and a transversal, and to identify and use the corresponding angles postulate. Here are some of the terms that we're going to be going over, and instead of trying to explain them all right now, I'm going to explain them as we go through the lesson, so it'll make it easier for you to understand. Okay, first we're going to talk about transversals. I got to get my pen going here. Let me change my ink color so it'll show up pretty well for everything. Okay, transversals. When a line intersects two or more lines in a plane, we call that line a transversal. And look at my color coding here. I put transversal in yellow, and then you can see that line T down here is my transversal because it's intersecting two or more lines in a plane. So line T is intersecting M and N. That's what makes it a transversal. So the intersection creates 8 different angles, and we give special names to certain pairs of these angles. And you'll see how we have 8 angles in the next slide. So think of 8 angles as being split into 2 different groups of 4. There's going to be one group around line M, and that's going to be, if you look in the picture, that's angles 1, 2, 3, and 4. That's my first group of 4. And then my second group of 4 is around line N, and that would be angles 5, 6, 7, and 8. And now I've color-coded the angles for you to help you see what's going on here. But angles 1 and 5 are called corresponding angles. And let me see if I can help you understand the word corresponding a little bit. Just in real simple, I hope, layman terms. I've got 2 tables here, and I got 3 seats at each table. Well, this right here, we're going to call the guy that sits there Bob, and the girl that sits here Sue. So Bob and Sue are in corresponding, that's a big word to write, seats. Okay, so what the word corresponding is meaning is, yeah, Bob and Sue are sitting at different tables, but they're in the same seat at their respective tables. Okay, they're both sitting right in the middle, so they correspond. So if you look at all these angles, let me draw, I'm going to put circles around them, or some of them. 1 and 5, see how they're positioned? 1 and 5 are parallel. Put a square around 2 and 6. I said parallel, they're corresponding. Angles 2 and 6 are corresponding, and then angle 3 and angle 7 are corresponding, and then angle 4 and angle 8 are corresponding. Notice their positions. Like 1 and 5, 1 is sitting on table M in the upper left hand corner, and 5 is sitting at table N in the upper left hand corner. So they're both in that upper left hand corner. Alright, now that was layman terms, not geometry terms. In geometry, we're going to say angle 1 and 5 are corresponding. 1 is at line M and 5 is at line N. Alright? Now let's look at alternate interior angles. They're in between the 2 lines that are not the transversal and are on diagonal opposite sides of the transversal. In this figure, they are the angles pair 3 and 6 and the angle pair 4 and 5. So let's talk about this a little bit. Whenever they'll give you pictures and they'll say, tell me what kind of angle pair angles 3 and 6 are. So what I do is I go and I circle those angles on my figure just like that, and then I say, okay, they are both on opposite sides of transversal. Okay, so they're both on opposite sides of line T, and I'm going to put line T right there for transversal, and they are inside parallel lines M and N. So this right here is going to be your clue. This is called like hen scratch, my little side notes to help me figure out what's going on. Opposite sides of transversal, that tells me, oh, these are alternate. All of a sudden I forgot how to spell it. And inside tells me that they're interior, and of course they're angles. And you'll always see me abbreviate this ALT period, INT period. Alternate interior angles. Hopefully that'll help you keep that straight. And of course it's the same story for 4 and 5. Now let's look at alternate exterior angles. They are outside of the two lines that are not the transversal and are on diagonal opposite sides of the transversal. So if they told me what kind of angle pair is angles 1 and 8. So first I circle angle 1 and angle 8. That helps me visually keep things together. And I look and I say, okay, they are on opposite side of transversal, and I'm abbreviating that this time, and I'm putting out there line T. And then I'm going to say, they are on the outside of parallel lines. Remember, that's the symbol for parallel, M and N. So opposite side tells me they're alternate. Outside tells me they're exterior, and of course they're angles. And that's how I abbreviate that. Alternate exterior angles. Alright. Same side interior angles. It's getting interesting. They are in between the two lines that aren't the transversal and are on the same side of the transversal. So that's where they get same side of the transversal. And in this figure, that would be pairs 3 and 5 and 4 and 6. So if I got a problem and they told me, tell us what kind of angle pair 3 and 5 are, I would look at those and I say, okay, they are on the same side. That's how I abbreviate same side. I'll come put it up here. Same side, that's how you abbreviate it right there. Interior angles. That's how I abbreviate those. So they are on same side of the transversal, which is line T. Alright, and they are inside parallel lines M and N. So same side, inside. So that means they are same side interior angles. And that's exactly how you would work it for angle 4 and angle 6. They're just on the other side of the transversal. Okay, postulate 3.1. Corresponding angles postulate. It says if two lines are intersected by a transversal, then corresponding angles are congruent. Okay, I went and stuck a picture in here for us right quick so I could talk to you about this. Okay, remember our corresponding angles? That's going to be like, uh-oh, I accidentally clicked to the next slide. Let me get my pen back. I must have lost it when I wasn't looking. Okay, remember angles 1 and 5 are corresponding angles. Remember, sitting at different tables but in the same spot. Okay, so what this postulate is telling me is they're saying if angle 1 and angle 5 are corresponding, oops, let me write angles here, angles, then they are congruent. But let me add right here that just a little side note. I put side note. M is parallel to N. If M and N weren't parallel, they would not be congruent. Okay? It only works with parallel lines. So that's why they put this in there. If two parallel lines intersected by transversal, then your corresponding angles are congruent. So that also means that angle 3 is congruent to angle 7. Let me put little asterisks there. Okay. It also means that angle 2 is congruent to angle 6. Put a little line there, just like that. And angle 4 is congruent to angle 8. Some nifty information. Okay. I mentioned this in our last CC, but I'm going to keep mentioning it again and again because I don't want you making this mistake. Do not ever assume that side lengths and angles are drawn to scale. And what that means is if you happen to see a drawing that looks like this, you cannot assume, I'm going to call this angle 1, you cannot assume that angle 1 is a right angle. It looks like a right angle, but you cannot assume that because it might be 89 degrees, it might be 91 degrees, it might be 90.1 degrees. You cannot make any assumptions. Now, if they have something that looks like this and they draw a little box there, then we can start assuming that we have right angles, because we're not really assuming it because it's given information. Or if they draw this drawing right here, but in a statement they say angle 1 is 90 degrees, then you're given that information. So it is 90 degrees. So please don't make that mistake. That's the most common one that I see students make. They look at the pictures, say, oh, that's a right angle. And then they start calculating it that way. And that's not correct. Don't ever assume. All right. This example says determine whether the pairs of angles are corresponding angles, alternate interior angles, alternate exterior angles, or same side interiors. Now remember what I told you earlier. If it tells me to look at angles 3 and 7, I go look at my picture because there's a lot of numbers and angles there. I circle my angles that I'm working with and I look at them really hard and I say, okay, here's my lines. They don't have names, so there's my lines. And then I can tell that this line right here is my transversal, the one that's going diagonally up and down. The other two are going sideways. So I look at angles 3 and 7 and I go, they are on opposite sides of transversal. And I also notice that they are inside the line. Okay, so remember, opposite means alternate, and there's my abbreviation. Inside means interior, there's my abbreviation, and their angles. So my answer there is alternate, interior, angles. There's my answer in big yellow letters. Okay, 8 and 6. Holy cow, look at that one. They are same side. Oh, look at me, abbreviating SS for same side. And I better put of transversal so I don't confuse myself. And, uh-oh, they're not inside the lines and they're not outside the lines. Oh, remember what we said? There's a table and there's a table. Looks like 8 and 6 are sitting at the same position of their respective tables. So that tells me that they are corresponding, and that's how I abbreviate corresponding, or I'll leave off the P and just use an S. Corresponding angles. Okay, now let's move on to 4 and 8. Okay, opposite side of transversal, and outside of lines. So remember, opposite means alternate. Outside means exterior for our fancy names, and their angles. So 4 and 8 are alternate exterior angles. All right, 2 and 3. 2 and 3. Okay, same side of transversal and inside the lines. So remember, same side just means same side. Inside means interior and their angles. So they're same side, interior angles. And let me add something here right quick that I forgot to put in earlier, and they don't even talk about it in this lesson, but they expect you to know it. Let's look at angle 1 and angle 4. Check those out. They're on the same side of the transversal, but they're outside the lines. They have a special name as well. We call them same side exterior angles. That's one that they're going to cover probably in your lessons, maybe on a quiz or a test, but they never mention it in the curriculum. So I just wanted to add that those are also an angle pair. Okay, let's look at this example. Now this is the kind I like. These are a big puzzle. It says in the figure, GN is parallel to FH. So I'm going to go right now and I'm going to mark that. If I can find my pen. There's my arrow. Remember, your arrows tell you, hey, those lines are parallel. It says the measure angle 10 is 60 degrees. And the measure of angle 12 is 40 degrees. And what we're supposed to do is find out the measure of all the other angles. So first, I look at this and I say, okay, I remember, I can't find my pointer to get rid of that message. Okay, I remember that vertical angles are always congruent. So that tells me that angle 9 is 40 degrees and angle 13 is going to be 60 degrees. I also know that a straight line has a degree measure of 180. So FH, segment FH, equals 180 degrees. So that means if I can take angle 13 plus angle 12 plus angle 11 is going to equal 180 degrees. So I got 60 plus 40, I'm going to put an X in there for 11, equals 180. It's 100 plus X, 180. I subtract 100 from both sides, so that tells me that angle 11 is 80 degrees. Now then, angle 11 and angle 14 are vertical angles. So angle 14 is also 80 degrees. But now I have to go up there and figure out what the measures of angle 1 through 8 are. So if you look carefully, you can tell this is why they told us G and F were parallel, is so that way we could see that angle 14 and angle 1 are corresponding angles. And remember that postulate we learned? Corresponding angles with parallel lines are always going to be congruent. So that means angle 1 here is going to be 80 degrees. And I know that 1 and 3 are vertical angles, so it's 80 degrees. Now then, let's look carefully. Angle 3 and 4 are going to equal 180 degrees. And how do I know that? Because angle 3 and 4 are a linear pair. I'm going to write that right here, linear pair. So angle 3 is 80 plus angle 4 is 180. Not 180, angle 4 equals 180. Subtract 80 from both sides. I know angle 4 is 100 degrees. So that means angle 2 is also 100 degrees because angle 2 and 4 are vertical angles. And remember, if this is going a little fast, push pause. You're allowed to push pause while you're listening to the recording. Okay, now I've got to figure out 5, 6, 7, and 8, and I don't have any parallel lines to help me out with this. I kind of do. Yeah, I do. But I can't use it yet because we haven't learned it. So what I'm going to have to do is I'm going to look at that triangle right in the middle. And I'm going to write up here somewhere. I'm going to put angle 3 plus angle 8 plus angle 9 is going to equal 180 degrees. And I know that because it's a triangle. And the sum of the angles of a triangle are always 180. Well, I know that angle 3 is 80. I don't know angle 8. And angle 9 is 40. So I've got angle 8 plus 120. I just added 40 and 80 together. And then I'm going to subtract 120 from both sides, and I get 60. So 8 is 60 degrees. Angle 8 and angle 6 are vertical angles, so angle 6 is 60 degrees. Angle 8 and angle 7, linear pair. So 180 minus 60 is going to give me 120. Angle 7 and angle 5 are vertical angles, so angle 5 is 120 degrees. There we go. I just love working problems like that. Alright, let's summarize here. If two parallel lines are intersected by a transversal, then the corresponding angles are congruent. That was the main thing we wanted to get from this lesson. When you get finished watching the video, of course, you need to go through the LMS lesson, complete your study guide, read through the reference guide, pages 69 through 74, and then complete problems 1, 2, and 4 in your problem set. And come on, do it. Anybody can work 3 problems. And after you work those problems, if you're not understanding anything, please come to Toga or IM me, K-mail me, ask me questions. I want you to make good grades on your quizzes. And I guess that's it for lesson 305, parallel lines and transversals. And thank you for listening.